Okay, so I'm recording this October, what is today? Days have been going by, so October 15th. So this is the day before the college is going to open, um, after we've gone through two hurricanes. We've gone through Helene and we've gone through Milton. So this is going to be a supplement to chapter 5. Um, Let me share my screen so that you know what to look at going forward here. Specifically, we're going to look at the calendar. So you should start seeing it here in just a second. Let me pause for a second. Come back. Okay, so I'm going to share my screen with you, and all I'm showing you is something that you've probably already seen before. It's the calendar. And if you're in my 10 o'clock class, it's the same information. So what you hear is just basically just switch it over to the 10 o'clock class. And so down here, you'll see where we are. So today is as I said, the 15th. We're going to resume college on the 16th, right there in the middle of the screen on the left. And then we were scheduled, remember, for test 2 on the 7th when we were hit by the hurricane threat. And then because of the damage that it caused, we had to delay it. And I don't think it would be wise for me to give it to you on that day we came back. And so we're going to do it on the 23rd. So a week from today, the day that I'm recording again is October 16th. 6 days from when the college resumes is where your test number 2 is going to be. And you'll hear some things today that will kind of overlap. So you may have heard me say in class that this is not a modular type of class where you can kind of go in and out. It's kind of a sequential class. So it's really important that you stay on top of things and you follow what I'm doing in class, because it all leads into the next thing. And if I didn't say it, hope everybody's doing well. I know I got hit with the hurricane. It knocked out my power and did a little damage to my house, but those are things that can always be corrected, and we can fix those things. So the other thing is, if you know somebody in the class that does not have power or needs to hear this message, please just forward them this piece. I'm going to have it. I may not be able to put it in Zoom in both classes, but I will definitely have it on my YouTube site so that everybody can access it via some mobile device. So let's get started. And I'm going to talk for probably about an hour or so. All right, so we're going to talk about stuff in chapter 5. And again, as I said before, you have already seen some of these pieces. And this topic is titled rational expressions and functions. And so you've seen functions before. Remember, we said that if we have a function that looks like this, f of x, and I kind of said that this was very similar to what y was, right? And you don't want to get this confused with the operation of multiplication. So this is not multiplication. Now, there may be some multiplication involved, but this notation here means something completely different. F represents the name of the function. And we can give it whatever name we want. And you'll see an example in just a second that we'll call it S. And X is what it depends on. So X are the values it depends on. So we're going to be plugging in some numbers to churn out some other numbers. So we may see a function that looks like, say, 3x plus 5, right? So there's the function, and we're going to be plugging in some values. And remember how this relates to what we've had already. So if I put, if I set up an xy axis here, and I say that f of x is equal to that last function, 3x plus 5y, 3x plus 5. X are my independent variables, the values that I plug in, and f of x, or y, is what this thing depends on to get values. So if I were to figure out, let's say if I were to try and figure out f evaluated at 3, where you see an x, you're probably want to set up some parentheses. I'll talk about that later, and just evaluate this. So this will give me 9 plus 5, or 14. And what that means on this graph here is if I go over 3 spaces on my x-axis, I'm going to get some value, maybe an increment here by 5s. So 5, 10, 15. So when x is equal to 3, my y value, or my f of 3, is equal to 14. So that is the value 3, 14, and sometimes you'll see it as 3, f of 3. So let's just say that, let's give you an example. You're trying to figure out, you're in your science lab, and you're trying to figure out how many spores are going to be formed on maybe a petri dish. So let's just say I have this petri dish, and I noticed that at some time there are so many spores on here. And I've determined that after a certain period of time, the number of spores triples. So let's just kind of duplicate this, see what we get here. So after a period of time, it looks sort of like this. All right. And so we notice that the number of spores triples. And we want to just create a basic function here. And so let's just say that our function that we want to call is going to be s of t. S because I just like that name, and it's going to make me remember that this is associated with spores. And this time the values, t, just represent time. And I want to be clear that maybe this is in hours. And so I create this simple equation that says that s of t is equal to 3t. And I claim to you that it will tell me how many spores I have every hour, right? So after 1 hour, we get S evaluated at 1. And so let's just say that we had 3 spores. And then at S of 2, maybe it was 3 times 2, so this was 3 times 1, or 6 spores, so on and so forth. And over here on the right side, let's give you a laser here. So over here on the right side, you can see that I have, let's see, I just simply tripled the number of spores that I had over here. So I'm going to have 15 spores over here. And so I can surmise maybe that maybe given this initial starting spot of 5 spores, that I can, maybe surmise that this object maybe was in the, and actually maybe my assumption might be I started off with 1 spore and it kind of morphed into something. So maybe after 5 hours, I get 15 spores. So maybe I'm here. So just making up just a basic example of how this might look. And if we were to graph it on an XY axis again, we would have, instead of X, we would have time. This would be T in seconds. And instead of Y, we would have S of T, which would be the number of spores. And this equation, S is equal to 3T, is going to look something like this. Okay? It's a straight line. Okay. Now, what we're going to need to do is we're going to need to also look at some values that are, if you will, good values. So let's stay focused on this line. And let's ask ourselves, what are the good values? Now, theoretically, this equation here, S equal to 3T, is good for all values, right? But we might want to just limit this to some values that are positive, because really we can't go back in time. So what we're going to probably want to do in this scenario here is, this should be values. And what we're going to probably want to say to ourselves for this, if we're going to try to explain it to our boss, we're going to say that the T values are going to be greater than or equal to 0, right? So right here is where T is equal to 0. This is the starting spot for this. And maybe this might be slightly off. So maybe I would probably move this up a little bit, because remember we said we're going to start off with, I think we said we're going to start off with 1 spore, and then thereafter it begins to triple, right? So then we go from 1, and then we go to 3, so on and so forth. I mean, theoretically, it's probably going to be it's going to multiply a little bit faster, but I think you kind of see what hopefully you can see where I'm going at. After 1 hour, we started off with 1, and then so on and so forth up the line here. Okay. And so we might want to say to ourselves, let's say if we kind of skip a little bit here, we might want to say that here at 4, this number is, actually this would be 4, sorry. So after 4 seconds or 4 hours, delete this part over here, because we started off with 1. And then after 2 hours, we get to 6. So this number is going to be, after 2 hours, we're going to be at 6. And then after 3 hours, we get to 9. Okay, so it might look something like this. And this number actually should probably start off at 3 after 1 hour. Okay, so there's our function. And so the bad values, we might want to say, are anything that is less than 1. So the bad values would be anything less than, I said 1, anything less than 0, because we can't go back in time. Let me change the color of the pen. Okay. So those values are what we call values in our domain. Right. So the domain is going to represent our, we'll just think of it as our good values. You're going to want to write this in 2 different types of forms mathematically. And so let's just start with the way that we have this set up. And so the way that we have this set up, we said that we're only looking at t values greater than, and we'll include 0, greater than or equal to 0. And so our domain, we're going to write 2 different ways. We're going to write in set builder notation, and you'll see me write the acronym SBN, and it's going to look something like this. So we have a curly brace, and it reads T such that T is greater than or equal to 0. And sometimes you may see it written as all T values that are positive or equal to 0. Right? I think this one is a little bit more explicit. And again, this reads T, and this little bar here means such that. I think you see the rest. The second type of notation that you're going to want to know is interval notation. It's going to express the same thing, but just in a different fashion. So different books are going to write it differently. So interval notation is going to look like, in this case, square bracket, 0, comma, infinity, open parentheses. And so what this means, and we have to distinguish between square bracket and open parentheses, means that square bracket means I include 0 in my values. If I didn't want to include it, I would have that as parentheses, such as I have over here. And so this means exclude. Okay. And so it may be read to you sometimes inclusive 0, exclusive infinity. Infinity never gets a square bracket because we can never get to the end there. Okay. And so those are the 2 types of notation that you want to be paying attention to. And so I'll use IN for the acronym there. Okay, so now that we've talked about some functions, let's put this together. This is why it's called rational functions. And so rational functions are basically fractional functions. And what we want to be mindful of is, well, a couple of things. The first thing is we're going to want to find the domain. And one bad thing about a rational expression or function is that we never want the denominator to go to 0. So we'll say to find domain rational function, make sure the denominator does not equal 0. So let's give you an example. I said nothing about the numerator here, so we're only paying attention to the denominator. So let's just say I ask you to find the domain of this function. I call it big G of x. You can call it whatever you want. And it's equal to 3x all over x plus 2. And so what you don't want to happen is you don't want the denominator to go to 0. We don't want this to go to 0. Remember, division by 0 in math is bad. And so we want to make sure it's undefined, actually. So we want to make sure that that denominator does not equal 0. All right, so here's what we're going to say is we're going to say that x plus 2 cannot be equal to 0. And that's pretty simple to solve. It means that x cannot equal -2. Okay, so let's put that off to the side over here so that we can kind of remember. And then let's see how we would write that. And the first time we'll write this in, we'll again use interval notation. So using interval notation, this is where we have the square bracket and the open parentheses. We're gonna kind of show using this interval notation, one kind of visualize a number line. And so here's my number line so you can visualize it. And here's -2. And we're good with all numbers on this number line except for -2. And maybe you remember this from a previous class. And so using interval notation, we're going to write open parentheses, minus infinity. We always go left to right from smallest to greatest. Greatest is going to be on the right, comma, -2. Now we're not going to include -2. So we open up parentheses and we kind of skip over it. And this is a union symbol, or and. Our solution is going to be our domain. It's going to be -2, again, not including it, comma, infinity. In set builder notation, it reads all x such that x does not equal -2. They mean the same thing. Okay, let's try it again. So this time, what we're going to do is I'm going to give you a function. And let's call it again f of x. F is just common. You'll see initially, you'll see that the names are going to change as you go down the line here. Okay. And so, but this time I'm going to say to evaluate at x equal to 5. So a little bit different here. So we're going to be, write a title up here, evaluating functions. And so what you're going to want to do, what I strongly suggest that people do is, well, this is what it means to do. And then up above here, right in here, is your key function. This is the machine that tells, what you're going to kick out. So you're going to plug in here. This is the value that you're going to evaluate. And then now I would suggest that everywhere you see an X, open up some parentheses. It's going to be a whole lot easier if you do it this way. And then once we do that, we're going to plug in that value that is inside of that parentheses. And so in this case, the parentheses is going to be replaced with 5. So I'm just going to plug in 5 and evaluate this. So the top you can see I'm going to get 13, and on the bottom I get 5. So this is what it means to evaluate this function. And if you want, you can put this in decimal form. This is about, what's that, 2.6. Goes in 2 times with, 3 left over, so about 2.6. All right. And so let's look at one more example, and I'll slow the video down, let you pause yourself as well. So if I gave you this function, and I said to evaluate, spell that right. So we're going to evaluate and find domain. Put it in set builder notation and interval notation. And so the function is g of x, and it looks like 2x minus 6 and x minus 6. So pause the video and see if you can figure it out. Okay, so let's first try to evaluate this. Oh, I didn't say what to evaluate it at. Sorry. So you're going to evaluate this at x equal to 6. All right. So now I'll go back and let you pause the video. Sorry. All right. So to evaluate this at 6, we're going to plug in 6 everywhere I see an x. So open up some parentheses everywhere you see an x, and then just plug in that 6. But now you may notice here that you have a value in the denominator that is equal to 0. And so this whole number, this entire denominator gives us something that we don't like in math. Division by 0 is undefined. So this is some undefined value. Okay. And so we can't evaluate it. If you were to graph it, you would see that this graph would jump right over the value of x equal to 6. And so if I ask you to find the set builder notation for this, in set builder notation, let's turn that to green. So SBN would be all x such that x does not equal 6. And in interval notation, it would be going from left to right, negative infinity, comma 6, union 6, comma infinity. Okay. All right. You're going to see some problems in your homework, so I would suggest that at this point, maybe you might want to get some practice. I would say after, get some practice and work through those homework problems. I'll probably finish up when we get back to class the remainder of chapter 5. So I'll probably only be able to get through about half of chapter 5 today, and we'll see. All right, so next thing we need to do is be able to simplify rational expressions. Now here's where the overlap is going to come with what you're going to see on your next test. So hopefully you've listened throughout this video, you haven't skipped over, because now you're going to kind of get a review inside of a lesson here. Remember, we've already reviewed for this test. So when we come back on next Wednesday, Wednesday the 23rd, I'm saying that right? Yeah, Wednesday the 23rd, you're going to have your test, because we've already reviewed the day before we went on. We left for the weekend before the hurricane threat was when we reviewed. So make sure you look over your practice tests and your homework. Okay, so let's say I ask you to simplify this rational or this fractional expression. So let's say it looks like this. So 3x to the 8th, y to the 2nd, all over 9x to the 3rd, y to the 4th. And I'm pretty sure you guys have come across this in your prior class. But what you want to make sure you understand here is that each one of these are monomials, one number. Right? So terms are separated by plus or minus signs. And in a second, you'll see one where you'll have a binomial, and even in some cases trinomials. So let's write that down here, and let's begin to simplify. So we can see here that these things cancel out. We'll get 3 of the factors to cancel with 3 up top here. We'll get these 2 to cancel here. And what we're left with on the top is a 1, 5 factors of x, and a 1 as well. On the bottom, we'll have a 3, that x to the 3rd right here, that became a 1. And some of you guys may already be saying, well, do I need to put that there? No, you don't, but you'll see why in just a second why I put that there. And then we'll have a y squared. And so most of you guys will already know that this is equal to x to the 5th, 3y squared. Okay, so monomial divided by monomial, pretty straightforward. Now, let's just say that I ask you to simplify something like this. So 2x plus 4 all over 2x. And so, but this time I have a binomial up top, 2 terms. And down below, a monomial. So this is very common. So you got to make sure you kind of get out of this bad habit. So what you don't want to do, let's write it right over here. So do not do this. This drives math teachers crazy. So if you have 2x plus 4 over 2x, you cannot do this. This is bad. Okay. So what you need to know how to do is you need to know how to factor. A little bracket around that to hide that away, because you never want to do that. All right, so what you must do you must factor to create common factors if possible. And this is where your skill from chapter 3 and 4 is going to come in. And so let's see if we can factor this. And so on the top right here, I notice, remember, that's the very first thing for pretty much all factorization process is to find a common factor. So the greatest common factor that I can see from the numerator is 2. So I'll factor out a 2, and I'll be left with x plus 2. And so now I have a monomial and a binomial on the top. And on the bottom, I'll have this monomial of 2x. And so when I go monomial on monomial, then I can cancel those factors. And then I'm left with x plus 2 over x. And this is it. This is my final answer, right? Because all we have left is we have simply a binomial up top, right? That's a binomial, and a monomial down below. And we can't cancel monomial on binomial. Right? So when in doubt, most of the time what I tell students is don't cancel. So when in doubt, don't cancel. You'll be better off, especially on higher levels of mathematics. You'll probably have to reduce a little bit more, simplify the fraction, but you won't get the answer wrong. You won't throw away the entire problem. Okay, let's try it again. We're going to simplify. This time I'll make sure I write it out for you. I'll give you a chance. I'm going to give you a chance to pause the video. So simplify x squared minus 9 all over x plus 3. Give you a chance to think about that. Pause the video. All right, so here's what you got to do. Again, now we have binomial and binomial, top and bottom, but they're not exactly the same. So they have to be the same in order to cancel. So if you recall, we had a factoring process called difference of squares. And so difference of squares factoring said that if we have a perfect square, and we're mainly focused on that numerator up there, perfect square is any exponent with any variable with even exponents. So x squared is an even exponent. And we have a second term that is a numeric value, another perfect square. So constants, you need to know those. I would say probably the first 13 perfect squares, 169 being the perfect square of 13. It's going to factor to be a plus b, a minus b. And so in this case, x squared minus 9, I can write it as x squared minus 3 squared And so when I plug in using my formula, in this place right here, I would put my x there and there. And in the second position, I would write my 3 there and there. One's going to have a plus, the other one's going to have a minus sign. Okay. So let's put that off to the side over here. And so now you should be able to see that this factors to be the top, x plus 3, x minus 3. And the bottom stays as x plus 3. I can't factor anything out. And then now I see I have a common factor. On the bottom, it just becomes 1. So simply x minus 3 over 1 or x minus 3. All right, let's try a couple more here. So let's say I ask you to simplify x squared minus 2 over x squared minus 4x plus 4. Again, we can see that these terms are not identical. These are considered factors, if you will. Right? They're not completely factored. The denominator can be factored even further. And so how can I do that? So what you want to do, again, for all factorization process, you want to look for a common factor. There is no common factor other than 1 or negative 1, but I think this term right here can be factored using my AC method. So recall the AC method of factoring. And so what we're going to do is we're looking at x squared minus 4x plus 4 to factor. We would ask ourselves factors of 4 that add up to negative 4, and that would be negative 2 and negative 2. And we showed you how to split the middle term using that minus 2 as a coefficient twice over. So you split the middle term, and then you factor by grouping. So this pair right here, there's a common factor of x. You'll have an x minus 2. That x minus 2 needs to repeat if I've done this right. Right, so just rewrite it. And you can see that I can factor out a negative 2 there. Now we're not done. That's just to help us get started. We can see that this x minus 2 is the common factor. So x minus 2 comes from there. And then what is x minus 2 being multiplied by? It's being multiplied by x, and again, a minus 2. So if you want to get fancy, you can write this as x minus 2 quantity squared. But we're just going to leave it as such. It's a little bit easier to recognize. Okay, so let's put that off to the side over here. So you can go back to that. But now we have the factorization for the denominator, and we're in great shape now. The numerator, I can't factor anything other than 1 or minus 1. And so we'll have x minus 2 times x minus 2. And so now I can factor out one factor of x minus 2. And now don't forget, there's still a 1 on top. That's why I was putting 1s way back here, just to make sure that you remember that it just doesn't go away. It still has some value there. All right, so now we'll have 1 over x minus 2, and we have simplified that. Okay. Okay, last piece here. We're going to combine everything that we've learned today. So I'm going to say, given this function, and I'll call it, we'll just give it a different name, h of x, it's equal to 2x squared plus 6x minus 20 all over 3x squared minus 5x minus 2. You're going to want to do a couple of things. So write function with numerator and denominator in factored form. We're going to ask ourselves for b, what are the restrictions x. We're going to want to know what is the domain of h. That's the function. Or d, we're going to write the function in simplified form. And we're going to do one more piece, but we got to do it before we simplify it. So let's do one more piece here. Oops. I'll change that to E. So D is we're going to evaluate at x equal to 5. Again, remember we gotta flip-flop these because we have to evaluate before you simplify. All right, so let's you can pause the video here if you want to move forward. Do it on your own. And I would suggest also that when you're practicing taking the test, do a bunch of problems as if you are actually taking a test, and then come back and look at the answer. That way you get that practice in. All right, so let's follow the steps here. So the first thing we're going to do, let's grab this. First thing we're going to do is write this in with the numerator and denominator in its factored form. So let's look at 2x squared plus 6x minus 20. First rule of thumb is pull out a common factor. 2 is a common factor. 2 divides into all of those. And now we're looking at this piece right here. 2 is already brought out. We're looking for factors of -10 that add up to 3, that middle term. And so I think we can use 5 and -2 to split the middle term there. So I would probably write that as x squared plus, and it won't matter if you put the 5 or the -2 first. So 5x minus 2x minus 10. The 2 is just going to get brought down each time. It's already factored out. And so here we're going to factor by grouping. So we'll have x times x plus 5. X plus 5 is going to be brought out from there. And And we should get a -2 here. Again, this 2 just gets brought along for the ride. And so you'll see that x minus 2 is multiplying x plus 5. Okay. Push that off to the side. And we'll do the same thing for the denominator now. So 3x squared minus 5x minus 2. There is no common factor, so we're looking for factors of -6. It comes by way of multiplying the first and the last coefficient. So we're looking for factors of -6 that add up to -5, the middle term right there, that coefficient. And so how about -6 and +1? And so 3x squared minus 6x plus 1x minus 2. Factor by grouping. So 3 times x minus, let's see. There's a 3x that comes out of that, actually. So 3x and x minus 2. And so x minus 2 is left over from that second pair, and we have to multiply that by +1. So this gets factored to be 3x plus 1. Again, just bring that down and that down. Multiply by x minus 2. And so there's your second factor. All right. So again, let's push that off to the side so we can see it. Pinch that down. And then now we're going to just rewrite those in factored form. So the numerator is 2 times x minus 2 times x plus 5. Denominator is 3x plus 1 times x minus 2. So that's writing it in with the numerator and denominator factor. Now don't simplify it at this point because we want to find out the restrictions. So what are the restrictions on x? So remember what we don't want to happen. We don't want the denominator to go to 0. So we don't want x minus 2 to equal 0. That means that x equal to 2 is a bad number. And we also don't want 3x plus 1 to equal 0. And that means that if we solve this, let's see, we would move that over to the other side. So 3x would equal to -1 or not equal -1. So x cannot equal -1/3. So these are my bad numbers. These are my restricted values. That should be a not equal to sign. So anything else is good as far as this problem. So this is part B. This was A. The third thing you want to do is find the domain. Well, the domain comes as a byproduct of what we just found. As I just said, every other number is good. So we'll use both set builder notation and interval notation. So set builder notation, all x, such that x does not equal 2 or does not equal -1/3. Okay. Interval notation. Let's see, I like to visualize this so I don't make a mistake. So on a number line, Here's my number line with all numbers. So negative 1/3 would be here. We don't want that, so we put an open circle. And 2 would be over here somewhere, so we don't want that. And so all the other numbers are good on this number line. So in interval notation, we'd have to write this in 3 parts. So it would be negative infinity, comma, negative 1/3. We always go left to right, smallest to largest. Union, negative 1/3, comma, 2. And then another union. Skip over 2, comma, infinity. So this corresponds to that interval, this corresponds to that interval, and this corresponds to that interval. Everything else is good except those 2 numbers. And then we want to evaluate this at 5. So part D, remember you want to evaluate first before you simplify. So I ask that you evaluate H at the value of 5. And so we're looking at this function up here. I like to use parentheses. So 2x squared plus 6x minus 20. And then below you have 3x squared minus 5x minus 2. So everywhere you see those open parentheses, you're just going to plug in 5. And then now you're going to use proper order of operation. Let's go a little slower this time. Order of operation says that you must do the exponents first. If there were any parentheses inside the parentheses, you would do that, but we've already taken care of that. So 2 times 25. So just do only the exponents first. Don't try and do all at one time. 3 times 25. So that's taken care of. Now we'll multiply. So in the numerator, I'll get 50 and 30. Down below, I'll have 75 and 25. So you want to kind of treat these as separate terms. So parentheses, exponents, multiplication, we've taken care of all of those. Now division, we can't divide yet because we don't have a common factor that we see clearly here. So you want to, again, treat top and bottom as sort of separate problems. So you want to do that first and that next. And so up top there, it looks like I got, let's see, 80 minus 20, so 60. And on the bottom, looks like I got 50 minus 2, so 48. I can reduce that. And see, here you probably already know that this can be simplified. There's a common factor. It looks to me like 4 at least. So 15 over 12. And it looks like I still can reduce that even further because 3 goes into that. Some of the digits adds up to something that's divisible by 3. So that's 5 over 4. Okay. And then finally, you want to simplify this expression. So And let's say this expression, this expression. So let me just copy that over real quick. We're almost done here, class. So you're gonna copy that. I'm gonna copy that down here for you. We call that h of x, I believe. Yeah. So h of x. And then now we can see common factors. So common factor, the only common factor is x minus 2, and I would leave it as it is. Don't try and push back the 2 there through. So there's your final answer. Okay, so again, hopefully this gets to you well. And we will be reconvening in class next Monday. Monday is got all my days mixed up here, the 21st. Take care.